Welcome to the screencast of TiCoNE, the time course Network Enricher. What's TiCoNE? TiCoNE is a clustering method with focus on time series data, interactivity, and network integration. Clustering in general is a popular technique to identify groups of similar objects in large datasets. In our particular case, we are dealing with time series data, so each object is associated with at least one time series. We can then define prototypes for each cluster by taking, for example, the mean or the median time series behavior of that cluster. And this is already enough to define the core idea of TiCoNE. We start out with an initial clustering. We can then calculate prototypes for each of the clusters. And then we can assign all the objects to the cluster with the most similar prototype. Then we end up with a new clustering, and we can recalculate the prototypes and reassign the objects. Every time we execute these two steps, we call it an iteration. TiCoNE is an interactive method, so at each iteration you can interact with the clustering, for example by splitting up a cluster, by merging clusters, or by removing objects which do not really fit to their prototype. And there's more. For example, you can add predefined clusters, you can delete clusters, or you can tell TiCoNE to keep a cluster even though it will change during the optimization procedure. TiCoNE is available as a Cytoscape app, a standalone implementation, and a web application. To the end of this presentation, we have prepared a small toy dataset, which consists of 3 clusters, each following a predefined prototype, which you can see here. Additionally, we generated objects for each of the cluster that follow the prototype more or less. To make the task more challenging, we also generated background, aka noise objects, which do not follow any pattern. Additionally, we generated a toy network which resembles the same cluster structure. Objects that belong to the same cluster are more tightly connected than objects of different clusters. The goal of this demonstration is then to recover the clusters we have hidden in data using TiCoNE. So now we are in Cytoscape. On the left side we have the Cytoscape control panel. So here we see a TiCoNE tab which pops up when you install the plugin. The first thing we have to do is to import our data. So for this I just downloaded the toy data from our TiCoNE website. You have to give it a name, which you can recognize afterwards, and you have to make sure that you, at least for this data set, uncheck this box, because we don't have a header line in this file. So then we can import the data. We import the network as well, the toy network. So to this end we downloaded the toy network file from the website, and again, because we don't have a header in the file, we uncheck the box. This is what we need to tell Cytoscape. So we click on column 1 and we tell it this is the source of the interaction and column 2 is the target of the interaction, and then we click OK, and Cytoscape imports the network and performs a layouting. Now we can start with the clustering. So we pick our time series data table in the drop-down box. So this is the table we've imported earlier. We named it data, and then we have plenty of other settings that we can set here, which I'm not going to explain in detail now. For this you can check out the website or the extended screencasts. The only thing I'm going to change is this value, which is connected to the p-value calculation based on a permutation test. So after a little waiting time, we are now presented with the resulting clustering. The clustering is a table consisting of rows for each of the clusters. So here you can see that we have 10 clusters, and for each cluster we have various values and a visualization. You can click on zoom to get a larger visualization of the cluster. Here you can see all the objects that belong to this cluster, and in fat bold is the prototype of the cluster. So now we have a clustering And we have imported a network. So maybe we are interested in seeing how these clusters are located on the network. And we can select network operations on the left side. And here we see the colorize network function. This for this function we need to select a set of clusters which we want to visualize or colorize on the network. I'm just going to select all of them, and then we click the colorize network, and we see that the nodes of the network are colored according to the clusters they belong to. Furthermore, TiCoNE provides operations to modify and interact with the clustering. So for example, you can merge clusters. Let's see whether there are clusters which may make sense to merge. So it seems that this guy, cluster 2 and cluster 6 look very similar. So I'm selecting them in the merge column. Then I'm going to cluster operations on the left side, and I click on merge selected clusters. So now we have one cluster less, as you can see here, and one new cluster with the number 11, which contains both of the clusters we merged. Furthermore, we can split a cluster. So let's see whether there is a cluster where it may make sense to split it up. For example, this guy. It seems that there is quite some variance in the objects of that cluster. So let's just click on the split button. And then we are presented with several options how to split it up. I'm just going to leave it at the default. So we take the two least similar objects belonging to this cluster, which are going to be new prototypes of new clusters. And then all the objects of the old cluster are reassigned to these two new prototypes. So up here you see the old cluster, and down here you see the two new clusters 12 and 13. Now we're clicking on save, and then we see the result again highlighted in the clustering table. The red cluster is the old cluster which we want to split, and the green clusters are the new clusters which originate from splitting the cluster. Now we can either say apply or discard. We are going to apply it. Now we can filter the clustering. So we see that there are some clusters where we still have some objects which do not really nicely follow the prototype. So what we can do is we can go to cluster operations again and click on filter objects. Now I will choose the least fitting object sets. This means that we filter out those objects which are least similar to their prototype. I'm going to select Pearson correlation and 50% of all objects. Then we click on delete objects, and we see that the clusters are much more sparse now because we deleted 50% of the objects. We can also delete clusters. So for example, if we don't like this guy, we click on delete, and then we are presented with several options. We can either delete only the objects that are contained in this cluster. This means that these objects are not reassigned to other clusters, but it means that the prototype of the cluster remains in the dataset, and there's a chance that other objects are reassigned to this prototype in the following iterations. We can also say we only delete the prototype and we keep the objects in the dataset, or we can delete both the objects and the prototype. So this is what we're going to do, and then it is visualized again as in red, and we can apply the changes. Now, as I already said, we can do either one single iteration, or we can perform iterations until the clustering converges to a stable clustering. That means that it does not change anymore. Additionally, to colorizing the resulting clusters on the network by picking the colorize network function, we can also perform a network enrichment analysis. The first approach simply extracts the node-induced subnetwork of the total network, depending on which clusters we pick here. For example, if we select cluster 11 in the KPM column, and we perform this network enrichment, it will extract us this cluster from the overall network, and we can have a look at it in the network visualization. Alternatively, we can use key pathway miner to extract maximally sized subnetworks which contain as many nodes of these clusters as possible with as few exception nodes as possible. Exception nodes in this case are objects which do not belong to, in this case, these three clusters. So I will leave it at these three clusters and select Perform Network Enrichment. And then we click on Perform, and in the backend, TiCoNE uses Key Pathway Miner to find the desired subnetworks. And now we are presented with a list of 10 maximally sized subnetworks with at most one exception node. So now we can click either on Show Union or Show Core, and then we can visualize this again in a new network. If you're then interested in which nodes belong to which cluster, you can select all clusters in the Visualize column and click on Colorize Network, and now you can see exactly which object originates from which of the three selected clusters.